Hi guys. Welcome to our channel Coders Arcade. This is Ashank David, and in today's live session, this is going to be our fourth live session of C++ object oriented, and my target is to complete this OOPS concept importance, which I have very importantly, for DSA prerequisite. In today's and tomorrow's class, we will be finishing it off. Till now, we have done it till here, where you have already seen that I have written the program. I have written this program, okay, where I have written this class car, and in the public section of the class like this, I have done the constructor, I have done the print detail function, and we have done this main method in this case, right. So, we have done it till here. So, now what we are trying to do is, in today's class we will be, 1 minute guys, okay, so in today's class we will be doing object oriented programming, and I will be telling you each and everything about object oriented programming. For the 4 pillars of object oriented programming, I will be telling you about inheritance and polymorphism today, okay. So, let us start from there, okay. So, now here in this program I have done 2 things here. First of all, I have created the class, and then I have created the main function in this case. Now, if you see here carefully, that I have explained you about what are constructors, what are destructors, how destructors are used, how constructors are used. So, if you have missed anything from that, you can go ahead and watch our previous live sessions. That was yesterday's and day before yesterday's live session. All the live sessions streams are recorded already and kept into our live playlist. So, if you have missed anything, you please go ahead and watch those videos also. Also, please do share this live stream as much as possible, so that those people who really need and want to learn about object oriented programming, they should get to know about this also, so that this is covered for them also. This is very important for DSA. So, we need to understand about this. So, share this playlist as much as possible. Now, without any further ado, let's get right into the concept. So, here today we are going to learn about inheritance and polymorphism. These are the 2 major pillars of object oriented programming. Yesterday I have just given you the brief introduction to them. Today I am going to go into depth of both of them, and I will teach you and I will make you understand about how this works, okay. Let me open up my Microsoft whiteboard, and here we will be creating our board for today's class. And in this case, in a moment I will be making it as black. Just a minute. Yeah, now it's much better, you can see, right. Alright, so here I will be today explaining you about the object oriented 4 pillars of object oriented programming, okay. The very first one was, as I have explained you, the very first one is gonna be our inheritance, okay. Then we are going to talk about polymorphism. Okay. Then we are talking about the abstraction. And then we will talk about at last encapsulation. Okay. So, today we are gonna do these 2 concepts, tomorrow we are gonna do these 2 concepts. So, we will start with inheritance first. I have already explained you that object oriented programming deals with real world entities, okay. It deals with real world, okay. So, these 4 pillars are also real world phenomenon. As you already understand that inheritance is what? It's a real world biological phenomenon, right. Similarly, Polymorphism is also a real world phenomenon where people tends to have many different forms, or anything can have many different forms of them. Abstraction is also a real world thing where we try to hide something to make sure that we understand the functionality of it in a more priority way. Then we talk about encapsulation. Encapsulation is the place where we are trying to, is the concept where we are trying to encapsulate or make everything secure, not accessible by everyone. So, we will talk about that also very soon. Let us move ahead and let us start with our first concept for today, that is going to be inheritance. Inheritance. Okay? Inheritance. So, what is inheritance? Speaking of inheritance, inheritance is a in general, in real world, it's a real world phenomena of characteristics being transferred from parent to child. Parent to child. Okay. Here, what is happening? The characteristics, the major important thing, the characteristics getting transferred from the parent to child. This is very important for us to understand in here. Okay. Parent to child. You see, we look like our parents, right? Your parents don't look like you. You look like your parents. Some of the traits are copied from dad, some of the traits are copied from mom. Am I correct? So, in this case, what happens is humans are a very good example of inheritance, where actual inheritance is that only where your parents' traits are copied into you as a child. Okay. So, in this case, the same thing has been improvised into our programming languages like C++. In object oriented programming, we have this inheritance concept which now allows us to use the contents of one class into another class without repeating them from one class to another class. Like without repeating, without rewriting all the concepts again from one class, similar to one class to another class, we can just make the use of them without writing them into another class. This is what inheritance means. I hope so that you are getting my point. So, in the terms of inheritance, let's imagine we have two classes, class 1 or let's take an example directly to understand this really well. Okay. Let's say we have a class calculator. Class calculator. Listen to this, class calculator. Now, in this class, I have written, this is just an example, guys. Okay. So, I have a class calculator, and in this calculator class, I have written add. For example, imagine that the calculator can perform addition. Okay. Then I have another class called as advanced calculator. Okay. I have another class called as advanced calculator. Let's say this advanced calculator can do subtraction. Okay. Let's say this class can do subtraction. Now, I am saying that there is another class called as class, we have super advanced calculator. For example, I am taking a super advanced calculator where this calculator can do product, or in simple language, multiply. You got my point? So in this case it can do multiply. So there are three things here guys. One is the calculator, another is the advanced calculator, and another is super advanced calculator. Now let's say calculator could perform addition and advanced calculator can perform subtraction and super advanced calculator can perform multiplication. Right now if I create the object of this class, say for example if I create the object of this class called as C object, calculator object, if I say C object for calculator class, this C object will be able to access only add right now. Understood? If I create the object of advanced calculator, so this is a C object, advanced calculator object, this can only perform subtraction right now. Okay, imagine, because of course if I create the object of that class, that object will be able to only access this, correct? Logically speaking, till now what we have learned till now, okay? And if I create the object of advanced calculator, according to what we have learned till now, this object will only be able to access the subtract function. Am I correct? If I create the object of super advanced calculator, SAC object, then this guy will only be able to do multiply, correct? Understood this? Correct? Till now whatever we have learnt, according to that I am saying, I am not applying any inheritance right now. I am saying according to what we have learnt till now in our previous sessions and classes, that objects are the instances which can access the contents inside the class, correct? And according to that if we see, then if I create the object of the calculator class, it can only access the add. If I create the object of advanced calculator, it can only do subtract, correct? If I create the object of the super advanced calculator, then it can only do multiply, correct? In this case, alright. But now guys, I am saying that I made calculator the parent of advanced calculator. I said calculator is now the parent of advanced calculator. That means this has become the parent of this. So this became the child of the calculator. Understand the point? So advanced calculator became the child of the parent calculator. Understood? So now what happens in real life? In real life, inheritance when happens, the parent gives the properties to the child, right? That is the parent and this is the child. So when the parent will give the property to the child, what will happen? This will make sure that this add function is also given to the advanced calculator without me writing the add function here. This function only contains add, while advanced calculator only contains subtract. But because now advanced calculator is the child of the main calculator class, calculator gave all its properties to its child. So in this case what happens is, now advanced calculator not only it will be able to do subtract, but also it will be able to do add as well. Are you getting my point, what I am trying to say? This example, are you getting my point guys? If you have any doubts, please let me know in the chat, because I can see the chat as well. Okay. So in this case, what is happening? This guy is the parent, this guy is the child. So parent will give all its property to the child, and now child was able to do its own stuff, but now it is able to do its parent thing also. So now advanced calculator, not only it will be able to do add, which is its parent thing, parent's function, but also it will be able to do this and its parent function. I hope so that this is very much clear to all of you, correct? I hope so that this is very much clear. Now I am saying that super advanced calculator is now the child of, this has become the child of advanced calculator, super advanced calculator. Now this what I'll do is, super advanced calculator became the child of advanced calculator. So now advanced calculator has become the, this has become the parent of super advanced calculator. Are you getting my point? Advanced calculator is the child of calculator, but it is the parent of super advanced calculator. Super advanced calculator is the child. That means according to us in human beings, super advanced calculator's grandparent is the calculator. Understand our point? In this case, what happens is that super advanced calculator, not only it will be able to do multiply, but also will be able to do subtract, which is its parent's property, but also it will take the property from its grandparent. In this case, what happens is that super advanced calculator can do add also, and it can do subtract also, plus it can do multiply as well. I hope so that this is very much clear to all of you what I am trying to say and explain. Understood? So this is how the inheritance works. Till now in your real programs, in your C++ programs, you were able to do only reusability only in one class, but with the help of inheritance, now you will be able to do reusability in multiple different classes by making one child a class, child class, and one another class as the parent class. In this case, ultimately the moral of the story is that if you make one class the child of another class, and if you make the another class as the parent of that class, they will share the property. Okay, where according to inheritance, according to the law of inheritance, parent will always have the tendency to give the property, while child will only be accepting the property in this case. Remember this law, guys, that parents will always give the properties to their child. So when I make this class as parent, then it will give all its property to its child, without me writing the parent's properties again for the child. This way I reduced the number of lines of code drastically, and my code is even small, but it is efficient as well. I hope so that this example you have understood really well. If you have any doubts, please do let me know. I will be clearing them right here. I can see the chat. Understood this? I hope so that this is very much clear. The link of this notebook I will give in the description below, so you don't have to worry about this example. It will be there. The link of this example and the whole notebook, this Blackboard, I will be giving into the description, so you can later on revise it from here. Understood this? This is the best example to explain you about how inheritance it works. Understood? Next up, we are going to talk about types of inheritance. Types of inheritance. Types of inheritance. Okay? Speaking of types of inheritance, how many different types of inheritances are there? Number one, we have single level inheritance. Then we have multi-level inheritance. Then we have, any guesses? Multiple level inheritance. Then we have hierarchical inheritance, and at last we have hybrid inheritance. Are you getting my point? So these are the 5 different types of inheritance that we usually see. I hope so that this is very much clear to all of you. Okay. So now starting from the very first one, I will be explaining you all the types of inheritances, but in your homework you will do the last one, okay, and I will give you the solution of this in the next class. But today let us understand about the first 4 types of inheritances, okay. Number 1, single level. In single level inheritance, there is only one parent and one child, okay, one parent and one child, okay. In this case it looks like this, where one parent is there and one child is giving all its properties, okay. Wait a minute guys. Okay, so in this case what happens is that this is the parent and this is the child. This is single level inheritance where there is only one parent and one child, okay. Then comes our multi level inheritance, where there is one parent, one grandparent, one parent and one child. How does it looks like? It looks like this, here, then here and then here, like this. A good example of multi-level inheritance is this example itself. That is the grandparent, this is the parent and this is the child. This is multi-level. We are changing the generations. So this has become multi-level inheritance. Hope so that you are getting my point, what I am trying to say, okay. This is the grandparent, this is the parent and this is the child, okay. This is your multi-level inheritance, okay. This is the first one, this is the second one, okay. This is the second one, okay. Now third one, I will show you third one right here. Multiple. In multiple what happens is, two parents, one child. In general means mom, dad and the child. They both are giving the properties to the child and child is taking both of their properties, mom's properties also and dad's properties also, and this is what you call as multiple inheritance, okay. So this is parent 1, this is parent 2, this is the child in general. I hope so that this is very much clear to all of you. Understood? Then comes hierarchical. In hierarchical there is one parent and multiple childs. I am gonna take up 2 childs for in this case, okay. So now fourth one is here, one parent and then multiple childs in this case. I hope so that this is very much clear to all of you. This is number 4, okay, where it is the hierarchical format, tree like structure, okay. So it starts from single point and then it goes on multiplies like this. So this is what your hierarchical inheritance means. Understood? That is your single, this is the single, okay, this is the second one, this one is the second one, multi-level, and this one is the third one, that is your multiple, and this one is the fourth one, that is hierarchical, okay. And then finally we have fifth one, hybrid. In hybrid you can combine any of these inheritances and you will become a hybrid inheritance. You will make a hybrid inheritance. In this case, let us say I have a multiple inheritance later on connected to multi-level inheritance. This is a good example of a hybrid inheritance, okay. Well, this is the parent, this is the parent, this is the parent slash child, and this is the child in this case, where in this case this is your single, and this is your multiple in this case. Single plus multiple you can say, or in this case you can call it as a multi-level also from one side of you. Understood my point everyone? This is the basics of inheritances. Okay, alright guys, you can see I will give you the link of this board into the description below, and that is your types of inheritances. Let's talk about how you can achieve inheritance in programming. Let's go towards the code and understand this very well. Okay, so I'm going to go towards the code, and this was the code which I have written now. I hope so that this is clear. I'll be clearing this off. I'll take up a new file, and in here I'll be doing the inheritance. Okay, so now let us see the inheritance part. Okay, let me explain you with the code part. Okay, we are into the coding part. Everyone can see the screen right here. Now I'm going to say here a class. Let's talk about the very first one, single level inheritance. Okay, so I said I created a class called as, what class shall we create? Let's create a animal class. Animal class. Okay, I created an animal class in C++, and let's say animal has void eat as a function. Void eat as a function. So in this case, let's say something is, I'm just printing here, we don't have to write this, but still I'm just saying something, that it is eating. Okay, class animal void eat. Okay, so animal has the eat function in it. Okay, now I have created a class called as, let's say, dog. Class dog. Okay, dog is one kind of animal, correct? So I created class dog, and dog has void bark in it, where the dog is barking. Okay, dog is barking. So I have two classes here, if you see. Okay, I have animal class where we have eat function, eating, and dog class where we have bark, barking. Okay, right now if I go in my main function, and if I say here we'll create the object. Oh, don't forget one thing, that is public, correct? Don't forget public in both the access specifier. Okay, I have already explained you about what are access specifier in session 1, so please, if you don't know about it, please go ahead and watch that. Next, let's say I have created the animal class example, animal class object. So I said animal obj, let's say obj, animal object. Object of A means object of animal. Okay, I have created this. Now I have said that obj of A dot, if I say here, wait, I will not write this because I don't have the default constructor in this case. So now if I say here obj A dot, you can see that the eat function is available, which is present here in this animal class, correct? So it can access the eat function. Now I created the dog class example. So dog D, I have created this object. Now if I say D dot, it has only bark function available. Okay, it has only bark function available. Understood? Now you see that dog can only bark, but it cannot eat, because dog is an independent class and animal is also an independent class. But now guys, I will make the dog as the child of animal class. And how? I will say after dog, I will say colon, full colon, one single full colon, and I will say animal right here. Okay. When I do this, automatically the dog becomes the child of this animal class, and when this happens, you see animal can still access only eat. Okay, animal can still access only eat, but if I say D dot, you see now it can eat also and it can bark also. I hope so that this is very much clear to all of you. Okay. Now you see here there is a, it says that the animal eat is inaccessible. When this happens, then what do? When you write the parent class name, just add public keyword there. Okay, public animal before it, and this will be gone. Understood? So what happens is now in this case is that dog can access both bark and eat, but you tell me, have I wrote the eat function in the dog class? No, but still dog object is able to access the eat function which is written inside the animal class. I hope so that this is very much clear to all of you in this class. If you have any doubts, please let me know. Okay. So this is where, this is an example of single level inheritance where this is one parent and this is one child, only one parent and one child. Hope you have understood this really well. Always remember parent, the law of inheritance, always remember the law of inheritance, that parent will give the property to the child, child will only take the property, children don't give the property back to the parent, but parent will always give the property and child will always take the properties. Understood? Here in terms of property means whatever the features of parent is, they are copied into the child without you rewriting them, hence decreasing the number of lines of code that you write. Where this is another good example of reusability in object oriented programming, which is not there in procedural programming. One advantage, and this is the first pillar that we are talking about in this case. So you understood this really well, I hope so. Correct? Right. This is a good example of single level inheritance. Alright. Let us go ahead and understand the next type of inheritance, and that is multi-level. In this case, or let me have it like this here only. Now in this case you have this animal class, right? This animal class is having eat and dog is having bark, as we know. Later on, let's say I am gonna create one more class here called as let's create one more class like baby dog. Baby dog or puppy, you can say baby dog or puppy. I am creating baby dog in this case. So I have said class baby dog, and this is going to inherit public dog class. And you see the baby dog started inheriting the dog class. Dog was already inheriting the animal class. In this case, when I start this, let us say in the public section of the baby dog class we have void weep, and I have written cout weeping, something like that. Okay. I hope so that this is very much clear to all of you. So what I have done is I have created the baby dog class, and this baby dog is accessing the dog class features, and dog was accessing the, so animal became the grandparent and dog became the parent and baby dog became the child. Understood? Well, I hope so that this is really very much clear to all of you. Alright. So in this case, see, dog can still access bark and eat. Dog cannot weep because dog is the parent of baby dog. Only baby dog can do all the three. So if I say here baby dog object as BD, so I can say BD dot, you see bark also is available, eat also is available, and weep is also available. So it can weep also, it can bark also, and it can eat also. Understood this really well? This is multi-level inheritance. You see, baby dog can weep, bark and eat, while dog can bark and eat, while animal can only eat in this case. This is very much clear to all of you, right? If you have any doubts, please do let me know in the chat. I can see the chat as well. Alright, let's move on. Alright, next up, this was multi-level. So, a single level is done, multi-level is done. Let us do hierarchical first. Okay, let us do hierarchical. So, let us say, rather than class baby dog and cat, baby dog and dog, I will create a cat, okay, which is directly inheriting public animal, okay, public animal in this case, where cat has the function, let us say meow, and this is meowing, okay, right. So, I have cat class which is directly inheriting the animal. As I have explained you, in a hierarchical we have only one parent, it is a tree like family tree structure, right. Well, we have animal class as the main parent and we have multiple childs coming out of it, multiple branches coming out of it. So, one branch is dog and another branch is cat in this case. So, what happens is that the animal becomes the parent and dog and cat are the independent childs of the parent animal in this case. So, do not do the mistake of inheriting the cat to dog, otherwise it will become multi-level and cat will also start barking, which you do not want to happen in your program, right. So, make sure that cat is directly inheriting the animal and dog is also inheriting the animal directly, and this is a good example of hierarchical inheritance. So, now in this case what I will say is instead of baby dog I will create a object of cat C. I will say C dot eat and meow only are available in this case, right. I hope so that this is very much clear to all of you. Cat can only eat and meow, alright, understood really well. This is the hierarchical inheritance. I hope so that this is very much clear to all of you. Okay, apart from this, this was 3 types of inheritance I have already cleared and I have shown you. Okay. Next up, let us create another class, another example, a good example that I am going to take you for multiple inheritance. Let us delete all this and now I am going to explain you the multiple inheritance in this case. So, I have a class called as, let us say, mom, class mom, okay, and let us say mom has a function called as void cook, void cook, see out mom is cooking, understood, okay. Then we have another class called as class dad, okay, where dad has a function void working, okay, anything we can take, work, void work, okay. I said see out, that is working, okay. I have taken this as an example, okay. Oh, and do not forget to write, again I am saying public, okay, do not forget to write the public, okay. So, mom can cook while dad can work. Now, there is another class called as void child, okay, void not void, class child, CHILD child, okay. Now, void class child, class will end with a semicolon, do not forget that, okay. Class child has a function called as void, let us say study, okay. and this guy is studying. Okay, don't forget the public. Okay, now I said that right now nobody is inheriting no one. Of course, mom and dad will not inherit each other, but child will inherit public, mom, comma, public, dad. And as soon as this happens, the child starts inheriting both mom and dad. Okay, let's verify it. So I'm going to say mom, m, mom object, m dot, only cook is available, right? Because mom is a parent. Then I have dad, d, and I've said d dot, only work is available because dad is a parent again. Then I have child, c, c dot, you see cook, study and work are all available. Is that clear to all of you? Cook also is there, child can cook as well as c dot, work also, and c dot, study as well. I hope so that this is very much clear. This example is way too much clear to all of you that now child is successfully able to inherit both mom and dad. This is multiple inheritance. C++ supports it, Python do support it, but disclaimer, for those who are doing Java, there is a surprise hidden, and that surprise is Java do not support multiple inheritance. This kind of inheritance Java doesn't support. Why? Why? Due to ambiguous nature of functions. Acha, imagine this. You have understood this part, right? You have understood this part, right? Now, see here. What will happen if mom and dad had the same exact method, or in this case function, whatever? Take an example. For example, mom has cook method. Now, example will replace the dad's work method to cook. Now, in this case, there are two cooks method. Mom can also cook, dad can also cook, and child can study. Child is inheriting both mom and dad, right? Then the question comes, in this case, dad can cook, correct? So, child, if I create the object of child and if I say dot cook and study, now there is only one cook and one study available. Question is, whose cook method is getting inherited, mom's cook method or dad's cook method? This is where the program gets ambiguous in nature, and this is the reason why Java doesn't support this, because there is no ambiguity resolution in Java which allows us to do it. But C++ does support multiple inheritance. That means in C++ will have ambiguity resolution. How? See here, while you are writing the object of the child and trying to access the contents of, let's say you want to access the mom's cook method first. So, I will say, for example, here the class name I will write mom, and then I will say cook like this. Okay. So, I have to write the class name also in the same time in this case. Okay. So, similar to that, when I say dad and then I will say cook like this. So, dad's cook method is now taken into consideration, I hope so. Okay. I had forgotten the syntax, guys, so my bad. This is how we do it. Okay. So, yeah, but anyways, apart from that, C can access its own study method also at the same time. Okay. So, I hope so that this is very much clear to all of you. Alright. So, this is how you do ambiguity resolution in C++ for inheritance, where we are able to do it like this. Clear? This is your multiple inheritance. Now, what we need to do is, what we need to do is, we will for your homework we will do the hybrid inheritance later on. In tomorrow's class I will give you an example of hybrid inheritance, that is going to be your homework. So, this is your inheritance over. I hope so that this is very much clear to all of you, alright. Okay. So, next up, this was your inheritance, and inheritance concept is over for us. Okay. Now, we have some time left, so we will start with polymorphism. Programs I will show you tomorrow, but let me explain you what exactly is polymorphism. Tomorrow's class we will finish up the polymorphism's coding part, and then later on we will be doing abstraction and encapsulation also. At the same time, it will not take much time, it will be very easy. So, now we will understand, we will start with polymorphism in this case. Okay. Let us start with polymorphism. Guys, polymorphism is one of the most important one of the pillars of object oriented programming. Why so? Because it is one of the most asked interviews questions. What exactly is polymorphism? What happens inside polymorphism? What is the use of polymorphism? What are the different types of polymorphism? Everything is asked. Understood? So, in this case, what happens is, first of all we need to understand is what is polymorphism. So, there are two words here guys, one is poly plus another is morphs. Okay. Polymorphism word is made from two different words, poly and morphs. This polymorphism, this poly and morphs, here you see that poly means many and morph means forms. So, the meaning comes as many forms, something which has many forms. What is the use of this in concepts like object oriented programming, if you ask? You see, if you talk about first real life, in real life what happens? All of you are polymorphic in nature, I can say that. I am polymorphic in nature, you guys are polymorphic in nature. How? What makes you polymorphic in nature, and what exactly is this? As I told you, polymorphism is a Greek word, actually this is a Greek word in terms of Greek. It has come from Greek words poly and morphs, means many forms. When we have many forms of something, we have many advantages also. So, what is the meaning of this? That meaning of this is many forms, but what is the use? In our real life, if you see, you are polymorphic in nature, I am polymorphic in nature, means we have different forms of us inside. For example, right now in front of me in this class, you are a student, correct? You are a student. When you go back to your house, in your home, in front of your parents, you are a kid, correct? Understood? On the other hand, let us take another example here. If I can only, I can say I am polymorphic in nature, okay? I have many different forms. I have a form where I can teach you C also. I have a form where I can teach you C++ also. I have a form where I can teach you Java also. I have a form where I can teach you Python also. I have a form where I can teach you DSA also. So, if I can teach only all these subjects, well, then why this company will hire any other trainer or a teacher? Understand my point, what I am trying to say? This is why, because of I am polymorphic in nature, I get the advantage. Well, in programming you are trying to do something like this only, where you are trying to make functions polymorphic in nature. Here, what do we make polymorphic in nature? We make functions polymorphic in nature. Always remember this. We try to make functions polymorphic in nature. Okay, we try to make functions polymorphic in nature. And what happens in this? Same function can do many different tasks. The same function can do many different tasks. For example, let us say I have two classes. I have created two classes. I have one class as class India. I have two classes, class India, where inside India I have def. This is not Python, this is C++. So void capital. I have a function called as void capital. Okay. Now this function is going to print Delhi. Okay. Then I have a class called as USA. Okay, where I am saying that in class USA I have another same name function called as void capital, where this can print what is the capital of USA? Washington DC. Okay. Now I have said, you see, observe one thing here, that we have the India class and we have the USA class. Both of them has void capital and void capital inside them. Okay. So what happens is, now I created the object of India. Okay. When I create the object of India, I can access this capital function. So I said obj India dot capital. Okay. Object of India dot capital. Same thing I have created the object of USA. So obj of USA as accessing the capital function in this case. See what's happening? There are two objects that I have created, object of India dot capital and object of USA dot capital. Okay. Can you tell me what will this object be printing? When I call the capital function from object of India, it will print Delhi. Right? And what this will print? It will print Washington DC. Correct? Washington DC it will print. Correct? Correct? So that will print Delhi and that will print Washington DC. Observe here that when I call this capital, it prints Delhi, but when I call this capital, it prints Washington DC. When USA calls, it prints Washington DC, but when India calls, it prints Delhi. I observe here in the above example, we understand this here, that the same named function capital is printing Delhi for India and the same name function capital is printing Washington DC for USA. So can I say here that the function capital has become polymorphic in nature? How? Because it can print both India and Washington DC. So it can print both Delhi and Washington DC in different states. When it is called from India, it prints Delhi, and when it is called from USA, it prints Washington DC. So I can say that the function capital is now polymorphic in nature. I hope so that this is very much clear to all of you. This is how polymorphism looks like, but more on this in tomorrow's class. As the time is over, guys, I want to conclude this class, and thank you so much for watching. I want to thank everyone to see and watch till the end. If you have any doubts, please do let me know. Today we covered up inheritance part. I hope so that you have understood this really well. I have explained you with the help of programs as well as polymorphism. I have just given you the introduction. In tomorrow's class again I will be continuing from here, and I will explain each and everything in depth. Well, that's all for today's class, guys. I thank you so much for watching this. Do not forget to like, share and subscribe, and also remember that we are also providing placements as well for those students who are looking for placements and they think that they will crack the interview. We will give chance, okay? But if you think that we are not able to, then we can train also. Well, that's it for this video, guys, and don't forget to come to the next live session for DSA at 6 o'clock after 1 hour. I'll see you later on after some time for DSA class. That's it, guys, for this class. Thank you so much for watching. This is Ashank David signing off. I'll see you next time. Till then, stay safe. Bye-bye.